right, so here I have actually 4 different power supplies in here, and inside of this bulb you see some metal spacing here, and this is all relating to some specs. Let me give you some information on these specs before I forget. So Angus, if you could get this information for them. Let me hold it over here. Is that better? I think you got to shoot this way.
That's right, yeah.
Oops. There we go. Got it? Then
So.
over here on this side, the whole page if you could. You can sweep down if you have to. Alright, there we go. Then we got to get these specs. This is just in case I forget to write this up. That's all. This focus on this side.
Yeah.
Okay, so you can pause the video and read that stuff if you need it. That's got all the specs for these devices. But now let's go ahead and see how it looks. Alright, so the first thing that I wanted to do was I turned up this heater right before we started. So there's a heater inside, and what that does is it creates thermionic emission of electrons. So basically there's a hot piece of metal. This heater causes that piece of metal to emit the electrons. Now as I increase this anode voltage here, what this does is if you watch there, oh, there's a beam. Can you see the beam yet?
Yeah.
Okay. And so I'm going to turn this all the way up to 300. Oops. Okay. And so what this does is it causes these slow-moving electrons emitted by the heater to be sped up by this potential difference. Basically a standard accelerator. Now over here we have a focus. This is just used to keep the beam dispersion. You can see here if I turn it off, the beam gets quite dispersed, so I'm going to try and lock that down. It seems somewhere right in this area is pretty good. Finally, I have these 2 coils here, and they're connected in series so that when I run current in such a way, you see that the beam starts to curve. Okay, so these coils produce a magnetic field. Now, let me just adjust this just a little bit here. Looks pretty good. Okay, and so what I want to do, if you can see the grid, can you see the metal grid at all? Hopefully you can see inside of there, there's a metal grid, and those grids are spaced every 10 millimeters. So if I adjust this a little bit, whoops, right there it's at the top of the circle. That should be about 10 centimeters diameter. For, hopefully that's a 3 centimeter. Can I get in there and look right on it? And then I'll turn the light down. Say right about there. Go ahead and take a look, and I'll fade the light a little bit. Dim out on you.
Yeah, maybe back up a little bit. There we go.
All right, and so now what I'm going to try to do is I'm going to try to adjust this anode voltage and the coil voltage. And so basically this changes the speed of the emitted electrons, and this will change the strength of the magnetic field. And hopefully we can see if all these equations that were written in these manuals then are valid. All right. Okay, so here's your first measurement. 300 gives you 8.7. Now I'm going to drop this down by 20. Oops. Well, it's not going to be exact. So we'll say 277, and I'm going to get in here, sorry. Right. So I got 8.3. What did I get before? 8.7? So hopefully that's a different number. Doesn't have to be exact. We'll go 255. I'm going to get in here. All right. Got an 8.0. Okay, so now trying to do the best I can. 237, 7.6. Okay. No, that's about right. I'd say 208, 7.1. See if we can get at least another one. All right, that's close enough. What is that? 179 and 6.6. Let's even go one more. It's probably going to get pretty tough. Okay. Whatever. Good enough. So what do we get? 151 and 6.1. All right. Let's call that good.